Teachers, this is our last session in this Reimagine Science Eco program. 6 months have gone by so fast, and I think we have all enjoyed every minute of it. Today's didactic is by Sharad. It's a very interesting one with just air, and he literally creates magic with air and a plastic bottle. That's about all that he uses. And then we have our the case study is by Ms. Sumana. She'll be showing us some very innovatively. She has recorded videos on light, and then we'll wind it up with clarifying questions, recommendations, and closing comments. Over to you, Sharad.
Thank you, Mama. Likewise, I am also feeling how 6 months have gone by. It was really very interesting. Yeah. And today's session is something which I'm naming as the air show, or the experiments which you can do with air. But what you will find very different this time is it's a mix of magic and science. So it's going to be really, really interesting. And there's something which you can show to the children at home and in the neighborhood. So we'll right away, without any preamble, without any theory, we'll jump into the magic show. Okay, are you ready? Okay. Though we just have 24 people, I wish we had more. But nevertheless, as we get into more exciting ones, I think people will join by then.
Yeah, they keep joining. So, yeah.
So you'll find different places in my house getting videographed because water was involved. My wife was not permitting to do it everywhere. Just let me know if you're able to hear the audio.
I have some hot water in this kettle, and I'll very carefully pour this hot water in this plastic bottle. One has to be very careful. The bottle can become hot. As you can see, the water is really, really hot, and the plastic is deformed, and with the help of a cloth I hold it and I empty this bottle. After emptying the bottle, I put the cap on tightly and leave it. See what is happening to the bottle. It is shrinking, it is contracting on its own. See, it is deforming. It has got further deformed, further compressed. Let me put it under the tap. It has got completely deformed, despite the fact that there was no hot water inside. Why is that happening?
Yeah, anybody? Why has bottle got deformed? Why it has got compressed on its own? Any views?
Because probably the pressure on the walls of the bottle was more on the outside than inside.
Yeah, Sheetal, the explanation is right, but why the pressure is more?
I can hazard a guess by saying probably when the hot
the
water
air
was
inside
there,
the bottle also became warm. The air inside the
became
bottle.
warm. Air contracts. All these answers in the chat are also right. Air inside contracts. Air pressure inside is less. These are all right answers. Yeah. Ramesh, sorry, I missed you. What did you say?
I'm going to hazard a guess by saying when we poured the water, hot water, it was all steam which had displaced all the other air. And once we put the cap on, and particularly when we ran it under the water, probably the water condensed, the steam condensed to water, which left us with a vacuum, and it collapsed the whole thing. Probably, I don't know.
Yeah. So all these are right answers. All these phenomena were in action as we saw in the experiment, and let me explain. When we pour water inside the the inside of the bottle, the air becomes hot and it partly gets filled up with water vapors, as Ramesh was saying, and then we close it. And then when we empty the bottle, so the hot water is no longer there, only hot air is there inside. And as we close it, slowly it starts returning to ambient temperature. And we know it very well that air expands on heating and contracts on cooling. So when the air inside starts cooling, naturally it shrinks in size. When it shrinks in size, the pressure inside becomes less and the pressure outside is more. So outside pressure is now pushing the bottle from all sides and it compresses. And partly what Ramesh also says is right. Water vapors are condensing, so they are occupying less space, and that's how the whole thing is happening. And when I put it additionally under water, it further cools, and this is what happens. So interesting, right? Okay, thanks for the answers. Thanks for participation. Anybody recognizes this small thing?
It's a pipette.
Not so technical, something very mundane, very basic.
Ink filler.
Ink filler. It's a dropper. That's right, Jashima. It's a dropper. No longer people don't use it because people don't use fountain pens these days. So what I've done is I have taken this dropper, and to this dropper I have attached a small nut, an iron nut bolt, as you know, na? So I have just put the nut over there, and at the end I have put some hot glue so that it doesn't fall off when I keep it vertical. Okay, understood this arrangement? Okay. Now let's see the experiment, or let's see the magic. These are not experiments; these are all magic.
As you can see, the dropper is floating in the water. The weight is attached here, but the water is filled up to here, and this portion up to the top is air. And because of the buoyancy of the air, the dropper is floating.
So have you understood? I'll just repeat this part. This is very important to visualize and understand. The dropper has water up to a certain extent. The top of the dropper has some air, and it is floating. I'll just repeat this part so that all of you are very clear about this.
As you can see, the dropper is floating in the water. The weight is attached here, but the water is filled up to here, and this portion up to the top is air. And because of the buoyancy of the air, the dropper is floating. Now, this dropper will obey my commands. I'll say, dropper, come down. And it comes down. I'll say, dropper, go up. It goes up. I say, be there in the center. Stays there. Why is it happening?
Now, why is it happening? Any guesses? Yes, Sheetal, you have raised your hand.
No, I said it is so amazing.
No, she said clap, clap.
Okay. Anyone? Why is it happening?
Sir, you're pressing the bottle like this.
Okay, Mary is a keen observer. She's saying, I pressed the bottle. I did. Yes, Mary, I did. And there was a noise as well, unfortunately, which also contributed to the fact that I was pressing it. Yes. What else? Buoyancy force created by pressing the bottle. Could you elaborate, Archana ma'am?
This looks like a futuristic thing. Like the dropper already knows where it will get more space, so it quickly goes down when you press it, and it's like it already has a mind of its own that it knows. If I go down, I will find more space there because somebody has holding the space there. Something like that. Amazing.
Yeah. Today all these things are amazing. Whatever you'll see, it's amazing, and it's all science. Yes, anybody? Otherwise, I'll go ahead and explain.
So when you press, okay.
Yeah, Sumana ma'am.
Is it
When you,
atmospheric pressure?
Yeah, please, one at a time.
sir, when you pressed it, actually the air gap, the top, I think the water moved up so that air pressure was reduced there in the top.
You are absolutely correct. I mean, you are correct to a very large extent. I shouldn't say absolutely. Yes, that's what happened, and I'll explain the remaining part.
Okay,
Yes,
thanks.
very nice. Thank you. Ramesh, you were trying to say something, perhaps? No.
No,
Okay.
no.
So let me move and explain this. What does Archimedes' principle say? First, a little bit of theory, a little boring thing. Archimedes' principle: a body, when it displaces when it is floating, it displaces certain amount of fluid on whatever fluid it is floating, and if the weight of the displaced fluid is more than the weight of the body, then body floats. Right? That's what essentially it says. I mean, very technical definition here, but I'm trying to make it simple in my own words. Right? This is how it floats. So when it is in this position, as you can see, when it is in this position, I'll just take the pencil. Yeah. So the dropper is here. It is having some air gap at the top, and the bottle is, one very important thing is, bottle is completely full. This part. Bottle is completely full. There is no air in the bottle. And why this is important, I'll tell you. There is only a small air pocket, which is there as shown in white, this one. And what are the forces acting on this one right now? There is a downward force because of the weight of the dropper itself, the weight of water inside the dropper, and the iron nut, right? These are the downward forces. We can call them FW. And what is the upward force? The buoyancy, because of the air pocket which is there inside the this one dropper, right? So this is providing the buoyancy. Right now, who is winning? The buoyancy is winning. So the upward force is more, downward force is less. And FB is greater than FW. Nothing technical here, just trying to put it so that everybody understands. And this is how it is floating. Okay. Now I press it. Mary, you are right. I press it from both the sides. Now, when I try to compress a fluid, there is no way a fluid can get compressed like that, right? We don't have strength to the molecules are so tightly packed. It is impossible to compress by hand. So what happens? The only air pocket available now where air can get compressed is inside the dropper, right? So the air inside the dropper gets compressed and some more water enters the dropper. And when that little amount of water enters the dropper, it makes it heavier and it starts sinking, because now the buoyancy is less and the weight of the water plus nut plus whatever the weight of the dropper itself is more, and it starts sinking, right? And when I release the pressure, again the air inside the dropper expands and it goes up. Now it needs some little amount of deftness to sort of bring it in the middle. Try to do it, and you can bring it in the middle and hold it steady over there, right? Any questions? Exciting? Very easily doable? Okay. Now, where do you think something like this is used in real life? Very, very important. I mean, yes, it's good as a magic, but very important use.
Flush.
Okay, Ramesh, you say flush. How's that?
I don't know. I've seen something on.
Okay, so there is something in flush olden days flush tanks. There used to be a floating ball, which used to, when the tank gets full, the floating valve will close the tap and the water will stop. Yes, something like this is used, but not in the way I am showing over here. Something very, very profound use.
Jaya says submarine.
Submarine. Oh, Jashi ma'am, that's really very good. Submarine. Now, how do you think a steel structure of this size, this magnitude, this heaviness sinks inside the ocean and comes to the top? So submarines have chambers, air chambers, and this is how it happens. I'll explain it. Let me just play it. Submarine is at the top. There are two chambers on the side. They fill up with water and submarine sinks. When when the water is thrown out of those chambers, the submarine comes to the surface. And this is how actually submarines go up and go down. You can watch a lot of videos online and you will figure this out. If you have seen some war movies, some submarine disaster movies, you'll be able to see these things happening. So what we have just designed, we have designed a submarine, right? In submarine, they use pumps to take out water. Here we are putting pressure to put water inside. That's the only difference. Okay. Any questions? Okay, we move ahead. Magic number 3. Okay. As you can see, I'm standing here with a strip in my hand. I just cut a small strip from the newspaper and I'm holding it to my lower lip, right? You can see that. And I'm about to blow air horizontally. I'm going to blow as hard as possible. I can do, still have enough lung power to do that. And let's see what happens. So something peculiar happens, right? Something very peculiar happens. I am blowing horizontally and the strip is fluttering and coming to the trying to become horizontal, not fully horizontal. It is trying to become horizontal, right? See it once again. Okay, just keep that in mind. No questions so far. I'll show you another magic and then we'll get on to the science behind it. Oh, wonderful. Deepthi ma'am has already said something. Keep it within yourself right now. Don't let the secret out. So what I have here, again, something very easily you can make. I have a cap, a bottle cap on which I have fixed a straw. I'll show you how I fixed it. And there is a table tennis ball, very lightweight table tennis ball, right? And what I've done is, as you can see, I have put some hot glue over here so that air doesn't escape. Okay, so it is a simple, very simple contraption. Now another thing, again, I'm trying to test my lung power. Something very easily doable. As you can see from my cheeks gone inside, I'm trying to suck air out of the straw. Okay, now what happens is like this. I'm sucking the air. So naturally bottle, when I'm sucking the air out of the cap, the ball sticks to the cap, right? Because I'm sucking air out of it. No explanation required, right? But now see the next one. Here I'm trying to blow. See it again. Now I'm blowing the air out of the straw. Still it is holding. No cheating here. I'm actually. So why the ball is sticking to the cap either way? It is sticking when I'm sucking the air. It is sticking when I'm blowing the air out of the straw. Yes, principle is used in aircrafts and helicopters. I would doubt, Sheetal, but aeroplanes. Yeah, I'll come to helicopter as well. Air pressure reduces due to high speed. Yes, removing air from underneath. Yes, that removing air from underneath explains the first one when I'm sucking air, but when I'm blowing, what happens?
It's the same reason due to the shape of the ball. The air tries to follow the shape, the spherical shape of the ball, and tries to go underneath it again, pushing it higher
Not
above.
really, Sheetal. What Deepti said is the scientific principle behind it. Air pressure reducer due to high speed. Let me just again get back to some science. There is something called Bernoulli's principle you might have heard. Don't get intimidated by his difficult name and the long name and the definition written over there. Simply put it, wherever there is a higher speed of air, the pressure in that area reduces. Okay. So go to the second bullet. First bullet is a verbatim definition, so don't get intimidated by it. Bernoulli's principle states that the higher the velocity of the fluid can be the liquid or air, the lower is the pressure. Okay, clear? Now what was happening in the first case? I'm just going back. What was happening here? When I'm blowing horizontally, there is a increased speed of air, velocity of the air horizontally at the level of my lips is increasing. So there is a reduced pressure of air, and the pressure on the strip down below is more because it is atmospheric pressure. Now that pressure pushes the strip up and the strip starts fluttering at the top. It goes up because I'm reducing the pressure. Bernoulli's principle, right? Same thing happens over here. The second one I'll say, yeah, sucking. This is actually blowing. Okay. So when I'm blowing into the straw, the air is coming out from the cap, and the air is at high speed over there. So the upper part of the ball has a reduced pressure, air pressure, as compared to the lower part of the ball. So the ball sticks to the cap. Okay. And this is what happens in the aeroplanes. Look at this. The design of the wings is something like this. If you take a cross section of aeroplane's wing, then this is how it is. And the air at the top, when the plane is taking off, the air at the top gets into a higher velocity, thereby creating low pressure at the top and high pressure down below, the normal pressure. And that gives a lift to the aeroplane, and the aeroplane takes off. There are so many more experiments you can do with this, but we don't have time, so I'm restricting myself to this one. Interesting. Another thing you can do is you can keep a TT ball in a funnel. So when you suck from down below, the ball will, or when you blow from down below, the ball will not get blown, because when you are blowing from the bottom again, there is a low pressure on the bottom and high pressure on the top, and it will not come out of the funnel, right? But when you keep the bottle, keep the ball in the funnel and blow from the top, the ball will jump out. Try that. Okay. I couldn't do it. I didn't have time, but it's a very simple experiment. Funnel, and you don't need a funnel again. Again, I'm saying just cut a bottle and that becomes the funnel. Okay. Magic number 4. Just let me have a little sip of water. Okay, a very, very interesting magic. I have a balloon, I have a water bottle. So what I do is I just insert this balloon inside the bottle and cover the top of the bottle with by folding the balloon over the mouth of the bottle. Clear? Okay. Now see the magic.
I have a balloon inside a bottle, and as you can see, the balloon is fully blown. There is air inside the balloon. But as you can see, the mouth of the balloon is open. But why is the air not coming out? See, it is open. Now I will command the balloon. I'll say, balloon, deflate. Stop. Deflate. What has happened?
So I have a whole lot of non-living objects who obey my command, a dropper and a balloon and whatnot.
And what about living objects? Do they?
Sorry?
No, do
Isn't
living
what the
objects also
diaphragm? Isn't the diaphragm doing the same thing when we are breathing in lungs?
No. Your muscles are really playing a big part over there. There is a hole in the, my goodness. Yeah. You have some clue over there. Very good. Very good. What else? Anybody? Okay. Interesting, right? Let's move. Let's get into the science part of this magic. So first of all, if you put a balloon in a bottle like this, try doing that. And however hard you may try, you may be a super person with all lung power, you will never be able to blow a balloon. Why? Why do you think you will never be able to blow the balloon in this position? Because when balloon is getting blown in a position like this, it will expand inside the bottle.
And there's air inside the bottle.
And there is air inside the bottle. That means air inside the bottle has to get compressed. And we don't have so much of capacity as human beings to compress air to that extent. It's only in the open air that the balloon grows because there is nothing to restrict the growth of the balloon. But here the air inside is getting. So try. People who say I'm very strong, give this to them. They will never be able to blow the balloon. Okay. So how did I blow the balloon? Somebody wrote over there. There's a hole in the bottle. Here is the hole in the bottle. So I cleverly made a hole in the bottle, and I blew the balloon. Okay. Once the balloon was blown, I closed it. With the finger, I closed the hole at the bottom. Now, there is equilibrium. Let's get to the science of it. If you blow into the balloon, it will grow in size. Growth will compress the air inside the bottle. This is beyond our normal capacity. This is what I said, right? But there is a small hole. Now, when I blow, the balloon grows. It displaces the air from inside the bottle. The excess air flows out from the hole, and that is how balloon can grow inside, right? Now I close it. Now balloon can deflate only if I allow the air to get inside. Otherwise, it is the equilibrium. There is a pressure from outside and there is a pressure within the bottle, which is the same. And even if the mouth is open, it cannot deflate, because if it tries to deflate, what happens? Low pressure gets created in the bottle, right? And there is high pressure from outside, so it will again try to go back, and that is the equilibrium which is now got over there. So when I say balloon deflate, sorry, somebody said something. No, I think some noise. Yeah. So when I say balloon deflate, I just remove my finger from the hole and allowed the air to get inside. And that's how the balloon got deflated. Look at it again.
I have a balloon inside a bottle, and as you can see, the balloon is fully blown. There is air inside the balloon. But as you can see, the mouth of the balloon is open. But why is the air not coming out? See, this is open. Now I will command the balloon. I'll say, balloon deflate. Stop. Deflate. What has happened?
Right? Okay. Ready for the next magic? Let's go. Again, my wife chased me to the wash basin because I was creating a lot of nuisance at home. This is very interesting. And Nadia and Mary, very sorry you said no canvassing, but here I am canvassing something for commercial gain. I sell this bottle for 50 bucks, including the freight charges. And this is a water producing bottle. I am sure the cities you're staying, there's a lot of water crisis. And this bottle produces double the water which you put in. So if I put 1 mug of water inside, it'll give you 2 mugs of bottle. So in the chat box, just say who all want it, I'll courier it to you. 50 bucks. 50 bucks. All apologies to Echo. Okay, have a look at it. This is my pre-order. Yes, wonderful. Thanks. I'll courier it to you.
What I have here is a magic bottle. This bottle produces water. I will pour 1 mug of water into this bottle and it will give me about 2 mugs of water. Let's see this experiment. So here I am pouring water. So it has started giving me water from down below. Let's fill this up. So 1 mug. Whatever I poured has come out. Some more is coming out. How is this happening? Any guesses? Water is
The
still coming
bottle
out.
already had some water.
But you know, why didn't it
Much more than
start
I
coming
expected.
out before?
See, you can't
if
say
it
that
had-
you're already buying this, huh? You can't say that.
No. But if it already had water, it should have started coming.
If it
Initially
already
itself,
had water,
right?
2
why it
mugs of
didn't
water
come
has
out?
come out.
It didn't come out at that time.
see,
He didn't
It's
open.
still coming out.
Actually, it is giving me more than 2 mugs. See, it was still coming out. Now, we have a water producing machine, right?
It looks that the water was already there in the bottle, and due to some capillary mechanism or something, when you put little water in it, it kind of, just
That
started
is
the
that is
flow.
a patent which I have submitted for approval.
Now I am going to sell it.
Okay, Kaveri Priya says pressure got built only after 2 hours. Oh my goodness. Yeah, that's one. 2 holes are made covered. Okay, no, not really. Not really. Something very basic which you did in your childhood. I'll come to that. Any more guesses? Any more orders? Why guesses? Any more orders? Everybody is interested in science, Ramesh. Nobody is interested in buying. Huh? They want to know the reason. Okay. So even at the commercial loss, let me reveal the details of my patented technology. Okay. This is what the bottle is inside. Looks like. Okay. So let me just take a pen and show it to you. Here the outlet is there. Down below, can you see? Uh, ah. So this is the from where the water comes out. Okay. There is a tube inside. From this, the tube enters. It goes like this. I'm sorry. It goes like this and curves all the way. And the other end of the tube is here inside the bottle. Okay. Understand this. One end of the tube is out here at this place. Tube goes all the way to the top up to this point, turns inside, and the other end of the tube ends somewhere here inside the bottle. So one end of the tube is inside the bottle. It goes into a U shape and then comes out from the bottom. Very clear? Anybody having any doubt in this configuration? Okay. Because this is very important to understand. I have some diagrams as well to make it very clear. So this is how it is schematically. Okay. So the end is coming on this side, and as many of you said, the water was already there inside. You were right. Water was filled up to say this level. How did I put tube inside?
Yeah, that's exactly what I wanted to ask you, Sharad.
Yeah, I'll come to that. I'll come to that. I'll explain the mechanism of making it. Let's first understand the principle behind it. Then I'll come to it. So as you can see, when you fill, take diagram number 1. This one. When water is up to this level, will it come out of the hole? There's no way it can come out of the hole.
No.
Okay. And what will also happen is that one limb, the left limb of the tube, if we divide the tube into 2 parts from the U or V, there is a left limb and there is a right limb. The water will enter the left limb. It will not be there in the right limb. It cannot be. Okay. Let's go to diagram number 2. This is the tipping point. Up to this level of water, nothing will happen. Isn't it? Water is still at the level of the curvature of the tube, and it is still filled up to this point on the left side of the tube, and the right side of the tube doesn't have any water at all. Clear? Let's go to the next one. Sorry, I got getting delayed. I'll go a little faster. Now I pour some additional water. What happens? The water goes over the U-turn of the tube and starts coming down from the other side, isn't it? It'll now get over the top of the U curve of the tube, and when it flows and it starts, when it goes to the other side, it naturally gravity pulls it down. Now, when the gravity pulls it down, it creates a vacuum there, so it sucks more water. It keeps on sucking, and this is what happens in third one and fourth one. It keeps sucking water from the bottle till what time? Till the water level reaches this stage.
Yeah.
And what principle is this? Siphon.
Siphon.
Simple principle of siphon. We have all been doing, and people of my vintage will remember, if my petrol in my vehicle used to get finished, I used to we used to keep a tube inside our scooters. And we used to ask a fellow, yeah, please, when we used to be in colleges, please give me a little petrol and let me reach the petrol pump. So we used to suck, take it in a bottle, put it in our scooter, and then move ahead. Simple principle of siphon. How did I put it inside the bottle? Yeah, that's a little tricky thing. Not tricky, but a little cumbersome thing. You take the bottle, put a hole inside the bottle at the bottom, push the tube from there. It will go straight. It will try to come out of the mouth. Then take something, pencil or something, and push it down so that it takes a curve, and then keep pushing it. Keep pushing it, and after some time it will form into a U shape. Try doing it, you will be able to do it. Okay, and then seal the bottom properly as shown over here. Put some M-seal or hot glue over here so that it doesn't leak. Okay, nice. Siphon. So another interesting thing is, can we do reverse siphoning? Think over this. We can discuss over chat. We don't have time right now. Otherwise, we can discuss what actually, if we have to do reverse siphoning. Suppose we have two containers. We are taking water from one container into another. Can we now start siphoning from the second container into the first container? Think over it. Okay, the last magic. This is the very, very exciting, very intriguing magic. Okay, let me start.
I have a water bottle here full of water. While you'll not be able to make out that water is up to here or up to here, but if I shake the bottle, you can see that water is up to here, right? Nothing unusual about it. The water is full up to this point, and there is a cap here. Now let me turn around this bottle. Oh my goodness, what do you see? The bottle is cut over here. I can actually dip my finger into this, but water is filled up to this point. How is it happening?
Interesting, right? Okay, so how is it happening? A bottle is actually cut from middle, and I've taken a lot of views over here. You can see. I have another video because in pictures it is not easy to visualize, so I've taken another one with putting potassium permanganate inside so that you can see some colored water. You can see the configuration, the state in which it is. Yeah. So one thing is very clear, there is no optical illusion over here. What you see is actually there. Huh? I'm not trying to fool you with something. Okay. Just trying to explain what it is, and then we get on to the scientific part of it, the science part of it. So what I've done is I've cut the water bottle like this on the white line, as you can see. And I have pushed the upper portion inside. Okay, the upper portion is pushed inside, and that's how it is. It is cut horizontally. Cutting horizontally is very important, and the upper portion is pushed inside, indented. Okay, clear? Now, if I make a hole in a water bottle like this, shown over here, what will happen? Water will flow out. If my water bottle gets punctured like this, the water flows out. Yes. But here I have made such a huge cut, and the water is not flowing out. It's staying there. Right? Quite intriguing. Let's see.
Till the cap is closed, it will be.
Sorry. Yeah, ma'am. What did you say?
No, if the cap is closed, it won't flow out. Once the cap's open, what happens?
Okay, once the cap, that's a good question. I'll open the cap and show you. Because this is the question usually a lot of people ask me, what happens when, but I'm asking, even if the cap is there, why it is not coming down? It's open, it's very much open. It's cut actually, but the fluid is completely inside, above the cut. Okay, we'll see this. So we have to really get into the physics behind it, putting all the forces where they are. Now let's see. Little, just play a little attention. Now, as you can see, the exposed portion of water. Exposed portion of the water is horizontal, right? Water is always finds a horizontal level. Here it is horizontal. Okay. The gravity acting on this portion, the water up to here, is pulling it down. So up to this portion, it's like an infinity pool, right? Or a glass of water full up to the brim. Nothing unusual up to this point. The water will not flow out. But we are more worried about the water in this portion. The water in this portion, which is above the cut, should flow out, right?
The water inside the bottle is experiencing downward gravitational force or downward gravitational pull. This surface of water is flat, it's horizontal, as you can see. Since it's horizontal and the water from here to here is being pulled down, it cannot spill over this edge of the bottle, because the only way to go is downwards from here. But this is an overhang. This column of water should come down from here and should get spilled over. Is that right? Why is it not happening? The water. Now, as you can see, the cap is tightly put over here, so no air can enter from the mouth of the bottle. So if this column of water has to come down, there will be low pressure getting created over here, and this pressure of water over here is getting counterbalanced by the atmospheric pressure on this layer of the water, and both are balancing each other. So what are the balancing forces? The pressure of the water here, the weight of the column of water up to this point is getting counterbalanced by the atmospheric force on the horizontal layer of the open surface of the water. If I open the cap, what will happen? Let me take it to the sink and show it to you.
So one correction here. I said weight, pressure of the water here. There's no water here. The air pressure here, okay, plus the weight of the water up to this point. These are the two things over here pushing it down. Correct? They are getting counterbalanced by atmospheric pressure, pushing this horizontal layer of the water, and they are in equilibrium. Why it cannot come down? Because as soon as this water up to from this level tries to come down to this level, what happens? A low pressure gets created here. It will not allow the water on over here. The pressure over here will push it again because there is more pressure over here. So they are in very happily in an equilibrium state with forces on both the sides balancing each other. But as somebody rightly said, and which is what I'm going to show you now, if I open the cap and allow the air from the mouth to get inside, naturally the water will flow out.
Now, as
This
you
is
can
what
see,
happens.
here we are. Now we are going to open the cap. See what happens. I'm allowing the air to come out, and the water flows out, and it comes up to the level where there is cut. Right? Here we are.
Now, the question here
Here
is,
we are.
how do you fill it up? How do you fill it beyond the cut?
Yes, my question was.
So I'll not reveal that. Try yourself. There are multiple ways in which you, once you do it, you will yourself figure it out. And if you don't, put it in the WhatsApp. But I'm sure you will be able to do it. So this is the end of my magic show, Magic Comes Science show. I was really excited in putting this. I had to really control myself. There are a dozen more magic and come science things which you can do with air. As you can see, they are so, we can't even call expensive. You don't have to spend anything to do all these experiments. Nothing at all, except you have to buy a dropper, which was the only thing which I bought, and a tube, less than $10. There's so much you can do with air. Thank you so much. I've taken too much time. I'll hand over to Sumana ma'am for her this one. Oh, sorry. It's going on. Yeah, over to you.
Yeah. Thank you, Sharad. So it was really such a nice. We all totally enjoyed all this magic and this experiments, all with just a bottle. It is which we can very easily do it in the classroom. So it was a very nice session. Now, Sumana, are you there?
Yes, ma'am, I'm here.
Yeah. So would you like to talk about your?
I would like to interrupt for.
Sorry. Sorry, Nadia. Thank you. Nadia will be sharing with all of you, since this is our last session, a post-test questionnaire in your email. Okay, so please fill it up and send it back without fail. All of us here at our hub team, as well as from ECO. So please do so. This is the post-test questionnaire, and this is because it's our last session over here. Yeah, thank you, Nadia.
Thank you.
So now, Sumana, please take over. Please, Sharad will be sharing the.
Thank you, ma'am.
Yeah.
Good evening.
Yeah. Good evening.
This is the